In this lab, we'll be looking at the acceleration of a car as it speeds up going down the hill. For this experiment, we'll need our track, the lab stand, the energy car, 2 photo gates, our timer, and connecting wires. See your teacher for the mounting hole height for your lab group. The track is mounted to the lab stand by passing the screw through the lab stand, threaded into the track, and tightened. The photo gates are attached to the track. Photo gate A is positioned at the first dark mark. Slid up underneath, finger tight just enough so it does not fall off the track. Photo gate B is mounted 10 centimeters below photo gate A. Again, it's slid up, finger tight, just enough so it doesn't fall off the track. Photo gate A is attached to the timer with the phone cord, push till the click. Photo gate A is attached to port A on the timer. Photo gate B, again, has a phone connector till it clicks. The other end goes into port B on the timer. The timer is turned on with the slide switch on the left side and push reset, and the interval light should be lit. If the interval light is not lit, push the yellow button until the interval light is lit. Place the car on the track. Adjust the stop screw so the car is within 5 centimeters of photo gate A. Release the car, allow it to pass through both photo gates, and catch the. With light A on, the time required for the car to pass through photo gate A is displayed. With light B on, the time required for the car to pass through photo gate B is displayed. With lights A and B on, the time required for the car to pass from A to B is displayed. We'll transfer the information from our timer to table 1. First, let's take a look at the table. Our position for photo gate A is at the start. It's at a position of 0. Photo gate B is located 10 centimeters along the track from photo gate A, so the position is 10 centimeters. Let's transfer our times. The time through photo gate 1 was 0.0155 seconds. The time through photo gate 2 was 0.0122 seconds. The time from photo gate A to photo gate B was 0.1357 seconds. Let's go and take a look at our calculations for the velocity through A and the velocity through B. The timer is started and stopped with the small flag that extends above the car. The length of that flag is 1 centimeter. So what we're looking at is how long does it take the car to go 1 centimeter. Our velocity is the distance it travels 1 centimeter divided by our time. Let's take a look at the velocity through photo gate A. My distance, 1 centimeter. The time it took, 0.0155 seconds. I'll put that in my calculator and I get a value of 64.5 centimeters per second. 64.5, I have my units, centimeters per second. Photo gate B measurements will be repeated for 20 centimeters, 40 centimeters, and 60 centimeters from photo gate A. Your information will be recorded in table 1. The step is to produce graphs of position versus time and velocity versus time for the data we collected. First, let's take a look at our position versus time. It takes no time to go from A to A. So at a time of 0, we're at a position of 0. At a time of 0.1357 seconds later, we're at 10 centimeters. 0.135 and 10 centimeters. Let's take a look at our velocity data. At a time of 0, we're traveling at 64 meters per second. Time of 0, and we're right about there. 0.135 seconds later, we're traveling 89.3 meters per second. 0.139, we're at a position right about here. Finish that out for the rest of your data table.